everybody, and welcome to Echo Live. My name is Anna, coming to you from the Michigan Science Center's Echo Distance Learning Program. What better day for a trip back to our virtual planetarium than today? Because right now we are in the middle of one of the hottest weeks of the year so far. Here in Detroit, we are experiencing quite the heat wave thanks to our favorite old star, the sun. So of course, we are joined here today by our staff astronomer and NASA Solar System Ambassador, Paulette, who's here to talk to us a little bit about the sun and how we can safely take a look at it up close. Hi, Paulette, how you doing out there?
It is hot. You are correct. So like Anna said, we are in the middle of a heat wave. And so we're going to take a look at our nearest star, the sun. Thanks to our sun, we have our warm temperatures that we're experiencing right now. And so we're going to be able to take an up close look. Now, here at the Science Center, as you can tell, I'm actually outside the Michigan Science Center getting ready for our opening tomorrow. At the Science Center, we have access to some special telescopes that allow us to look at the sun safely. But before we take a look at the sun, we're going to talk a little bit about some of the things that we might be looking for when we look at the sun safely. Now remember, never, ever, ever, ever stare directly at the sun because it can hurt your vision, it'll damage your vision, and you could go blind. So please, please, please never, ever, ever stare directly at the sun. But here at the Science Center, like I said, we have a couple of ways of looking at the sun safely. We have special filters that go on this telescope right here, and we'll talk a little bit about that in just a moment. But let's go ahead and take a look at some of the things that we might be trying to see on the surface of our sun. It's a little hard for me to see out here right now since it is so bright outside, so I might disappear for just a second out of my camera. There we go. So here we have an image of the sun. This is what it would look like in visible light. Now, what are some of the things that we notice on the surface of this sun right here? Now, like I said, it's a little tricky for me to be able to see what's on my computer. So Anna is going to be helping me out today. Whenever I ask a question, remember, use that chat feature to answer the questions or ask any questions of your own. And Anna will be feeding me those questions during our program today. So what do you think these spots on the sun might be called? What
Evan from Texas told us they're called sunspots. That makes a lot of sense.
That does make a lot of sense. They're exactly called sunspots. Sunspots are darker areas on the surface of the sun. Now, those darker areas are about 10,000 degrees Kelvin cooler than the rest of the surface of the sun. The surface of the sun is about 6,000 degrees Kelvin, and those spots are about 5,000 degrees Kelvin. But the coronasphere, the thing that goes around the sun, that's sort of, when we think about the sun and we draw it with the little spikes coming off of it, that would be the coronasphere. That can get to about 1,000,000 degrees. So that is much, much hotter. But the surface of the sun, of our nearest star, is about 6,000 degrees Kelvin. And it's starting to feel a little bit like that outside here today. It feels like about 95 degrees. And it is definitely a warm one. So some of the other things that we might be able to see if we're looking at the sun in different wavelengths of light are not just these sunspots, but we might also be able to see some things coming off of the surface right here. Now, does anyone know what we might call these things coming off of the surface of the sun? Sometimes they're pointed towards us. Sometimes they're just pointing out towards space. Sometimes those go out and then back into the sun. What do you think we might call these things coming out of the sun? There's a couple of different names they go by. So what do you think they might be called?
No answers just yet, but Evan also told us that it is 104 degrees in Texas. So count yourself as lucky out there, Paulette.
Oh my goodness. I did live in Texas for a little while, and there's a reason I moved back to the Midwest. So what do we think these things coming off of the surface of the sun might be called? This is a really tricky question, and it's okay if you don't know the answer. Some of these things are called solar flares. So when they come off from the surface of the sun and they blow out into space, that's what we call a solar flare. Sometimes, like these loops that we see right here, leave the sun and go back in. Those are called solar prominences. Now, when we take a look at the sun in different wavelengths of light, we're able to see those solar prominences. And that's actually what the telescope that we have right here is for. Now, I do want to mention to you all that right now we are in a time of solar minimum. So sometimes the sun is more active than it is at other times. So we're actually right in 2020. I can't point it out with the pointer, but we're right in 2020, and you'll notice that we have 0 sunspots. We've had just a few sunspots on the sun this year. So the sun is not particularly active. There's not really a lot going on, but it's something that we were expecting to be able to see. We were expecting a solar minimum in 2020. Now, hopefully by 2025, we'll be reaching again our solar maximum. So right now we're at our minimum or our low point, and we'll be able to see more and more sunspots until we reach 2025, and it should dip back down after that. The sun is actually a really reliable object to be able to count on these sunspots. It really does take the same cycle year after year. So, like I said, we really were expecting a time of low solar activity, but we actually are seeing a very, very low time of solar activity right now. All right, so we have, like I said, a telescope right here. We were able to purchase these telescopes thanks to the Community Telecommunications Network, or CTN, and they have allowed us to be able to take these telescopes out to the public and teach people about astronomy or seeing things that they might see. Now, this is a specific, fancier telescope called a Coronado. So this is our Coronado Telescope. And the Coronado Telescope allows us to see the sun in a particular wavelength of light called hydrogen alpha. So hydrogen alpha allows us to see those solar prominences that I was talking about. You're able to see a little more of the corona from our nearest star than you are with visible light. And we'll be able to take a look at the sun in visible light as well. But we're going to start with this hydrogen alpha first. So the nice thing about these telescopes is I actually have this hooked up to my cell phone. So I'm going to be able to show you through my cell phone what you're able to see up in this part of, there we go. All right, now you should be able to see something that kind of looks a little red, and it's because it's not quite in focus yet. But if I move this around a little bit, this might take me just a second, because I don't have a tracking telescope. All right, now do you see that right there?
Looks like a big red dot.
It does look like a big red dot. Now, the reason that this is red in color is because of the filter that we're using, that hydrogen alpha filter. Hydrogen alpha is in the red or pink part of the spectrum, so we're really only able to see it because of that. Now, if I zoom in just a little bit, let's see what we can see. Not too terribly much going on the surface of our sun right now. So you see we don't have any darker spots, and we also really don't see any solar prominences. Nothing really coming from the surface. Now, since this is a little more difficult to see, we're going to go ahead and actually switch to our other telescope. So the other telescope that I have for us today is something called a Sunspotter. And here we have our Sunspotter. Now, this probably does not look like a traditional telescope, right? We have a lens right here in the front that allows the sunlight to reflect off of a mirror, and it actually projects the sun down on this piece of paper that we have right here down on the bottom. So we're going to set up this Sunspotter right here. And I'm actually going to grab out my phone so that we can use that camera for this instead. There we are. So we have our Sunspotter right here. Everybody sees it? And you can also see a few of our footprints leading up to the Science Center. We are, like I said, getting ready to open. Tomorrow is our first day. If you're interested, make sure to register for tickets online. But we have this Sunspotter. There's a lens right here in the front. And then we have, right down over here, a mirror that reflects the sunlight up to another mirror right over here. And then it gets through this mirror right here on the top and through another lens right down over here. So we're going to be able to see the sun down here on my piece of paper. So we're going to go ahead and aim this right at the sun. And this is actually a really nice and safe way to take a look at the sun. This is one of my favorite ways, especially because right now, having all of us look through telescopes is a little bit dangerous because we don't want to be too close to each other. We don't want to get germs on each other. But this one actually allows us to all see our sun at the same time. And there it is. There is our sun. And again, looking through it, we don't see much really going on. And that's because we're in that time of solar minimum. So we're really not able to see too much when we take a look at our sun right now. All right. So our sun is at a time of solar minimum, but we're hoping that in the next couple of years, we're going to be able to see the sun get more and more of those sunspots. Now, earlier this week, I made something called a solar oven. Anna, do you happen to have the solar oven downstairs so we could show it to people?
I do. You'll have to give me just a moment because I threw it out in the hallway and didn't throw it in the trash, just outside the door.
Yeah. I totally forgot to bring it outside with me. I had a lot of equipment to bring out here, especially with our telescopes. Now we can use the sun to our advantage. Just because it's super, super hot outside doesn't mean that we can't do something fun with the sun outside. So Anna has in her hand my solar oven. I took a pizza box and cut a hole in the top of it. And there is saran wrap over the hole. Anna, why don't you show them all of the different parts and features?
Yeah, so like Paulette said, she cut almost like a hole on 3 sides right here so that we could open the top like a flap. And then she covered it with some aluminum foil so that you can actually reflect the light from the sun down into your oven. And correct me if I'm wrong, but I believe that one of the technical terms for this oven is that it's a collection oven because it is collecting thermal energy, which we are harnessing from the sun. Yep, and so the light would reflect off of our top flap here down through the saran wrap, which Paulette used to cover this bottom section, the hole that she had cut. And inside, this won't break it, but I am going to open it up so we can take a look at some of the inner components here. We have some black construction paper down on the bottom. And Paulette, is there a specific reason we chose black construction paper?
Yeah, so we chose black construction paper because black absorbs sunlight. For example, I really shouldn't be wearing a black t-shirt outside because it makes it way, way hotter. black absorbs all of the wavelengths of light that reach it, and that's why it appears black to us. That's why black is going to heat up. If you've got a black car or black seats in your car, you've probably experienced this yourself, where it gets a lot hotter than if, for example, you have a white car with tan seats.
So all the light then, like Paulette said, will reflect off of our tin foil down onto the black paper where it gets absorbed, causing our oven to heat up. And then the last thing we added was this layer of newspaper all around the outside. And I believe this is here as insulation to trap all that heat inside and not let it escape from our oven. And Paulette, do you have a favorite solar oven recipe? What do you like to cook in your solar oven?
I like to cook nachos.
Ooh, good one.
So what I like to do in my solar oven is you put a whole bunch of chips in it, of course on a plate or saran wrap or something like that, so it's not directly on the paper box. But I like to put chips in there and then sprinkle it with some cheese, some jalapenos, maybe some tomatoes, and I like to make nachos in mine.
Yeah. Well, I will disclaim to everybody that these solar ovens can get really hot. You do have to leave them outside for quite a long time in order for them to fully heat your food all the way through. So I wouldn't recommend cooking anything inside one of these collection ovens like raw meat, something that needs to be heated to a certain temperature for a period of time. But you can make things like chips and cheese because all of that is pre-cooked and ready to eat. One of my favorite things to do is make a solar oven s'more. And so you can actually roast, or not necessarily roast because you won't burn your marshmallows, but you can warm up and warm your marshmallows and your chocolate down here inside the oven. And this oven, unlike your oven at home, is safe to leave outside for a little bit because we said it takes a little bit of time. And so you would just prop up the lid to your oven at the correct angle. You can use something like a ruler or a wooden spoon, and it's safe to leave this oven outside for an hour or so while it gets warm enough for your food inside to get nice and gooey and delicious. But this is pretty cool, and all stuff that I think most people probably already have laying around at home. If you don't have a pizza box, really any sort of box would work. A cereal box would work as well.
Yep, and I have a ticket. I actually didn't order pizza. I went to one of the local food service stores, and they sold pizza boxes.
Oh, very cool. Couple people who just popped in. Remember that if you have any questions for today, for Paulette about the sun, which is what we've been talking about our collection oven, which we've made right here. If you have suggestions for things you think we should cook inside our solar ovens, I am all ears. We'll take this moment really quick, as we always do, to thank the sponsors of Echo Live, like Ford Motor Company Fund and Denso. They've allowed us to bring these programs to you for free all throughout quarantine and even throughout this summer. Our schedule this summer is continuing on every Tuesday and Thursday at 2:30 p.m. Eastern. You'll get to hear more from me and our other MySci educators, and Paulette will, of course, keep thrilling us with these awesome virtual planetarium programs. And I think in a few weeks, we have a very special NASA update coming up about the, Paulette, what is that update going to be about?
Yes, so that is going to be about the Mars 2020 rover, also known as Perseverance. So that's going to be launching pretty soon, and I'm super excited. But before we go, I do want to mention something that has been up in our nighttime or in our morning sky that some of you might have seen for yourselves. Right now, there is a comet that is visible to the unaided eye in the northeastern sky. So if you go outside shortly before the sun rises, and you look to the northeast, you will see really close to the horizon, kind of close to the star Capella, you'll find a comet. Now, unlike comets that we see in TV shows or anything like that, they don't zoom across the sky. But this one will be there. You'll be able to see the big long tail. We're going to talk more about comets next week, but I wanted to let you know that if you wake up right before the sun rises, look to the northeast and try and find that Comet Neo. It's going to be really, really fantastic. And hopefully after it makes its path around the sun, it won't break up like most comets do. We'll talk about that next week, but that it'll still be visible from where we are.
All right, a couple questions before we head out, Paulette. Howard would like to know this very scientific question, of course. Is the sun's corona contagious?
That is a fantastic question. You know, I actually did a program this morning and somebody likened the corona around the sun to the coronavirus. So, Howard, that is a really great question. So, no, the sun's corona is not contagious. The word corona means crown. It's Latin for crown. So the coronavirus is actually a virus with all of these little things sticking off of it, if you've seen an image of it. So it'll be round with those little things sticking off of it. So that's why they call it coronavirus, because of the shape. We have the corona sphere around the sun. And there's a lot of there's corona borealis, the crown of the north. So there's a lot of things that use that word corona because it's Latin for crown, but it isn't always necessarily has to do with the coronavirus. They're two very different things, but still a great question.
And just like you would protect yourself while we're out right now by wearing your mask, you should, of course, still protect yourself from the sun by wearing your sunblock. Paulette, I'm not sure you put on your sunblock today, but reminder to you, sunblock always.
Yes, hopefully I won't be a lobster after this.
All right, everybody. Evan asked, what is our next video? Raul is actually going to be here on Tuesday to talk to us about another automotive engineering design challenge. It's going to be a very cool episode. We're going to teach you how to design some of your own aerodynamic vehicles. So make sure you come in, check it out. We will see you next week. Paulette, thanks so much for baking out in the sun with us today. We will see